This unit will be about number systems, and specifically about the binary system as the basis for the work of a computer system. Main number systems are the following: binary, decimal, octal, and hexadecimal system. Work of a computer system relies on a binary system. Information are processed and stored in computers as electrical signals. A computer contains thousands of electronic circuits connected by switches that can only be in one of two possible states: on when the current is flowing through the wire, or off when the current is not flowing through the wire. To represent these conditions, we use binary notation in which 1 means on and 0 means off. This is the only way a computer can understand anything. Each 1 or 0 is called a binary digit or a bit. We can say that the bit is the basic unit used to measure the amount of information. Ones and zeros are grouped into 8-digit codes that typically represent characters, letters, numbers, and symbols. 8 bits together are called a byte. Thus, each character in a keyboard has its own arrangement of 8 bits. In order to avoid astronomical figures and sums in the calculation of bytes, we use units such as kilobytes, megabytes, and gigabytes. 1 kilobyte equals 1024 bytes, or 2 raised to the power of 10, and it is represented as KB. 1 megabyte equals 1024 kilobytes, or 2 raised to the power of 20 bytes, and 1 gigabyte equals 1024 megabytes, or 2 raised to the power of 30 bytes. We use these units, kilobyte, megabyte, and gigabyte, to describe the RAM memory, the storage capacity of disks, and the size of any application or document. The majority of computers use a standard system for the binary representation of characters. This is the American Standard Code for Information Interchange, known popularly as ASCII. There are 256 different ways of combining 0 and 1 bits in a byte, so they can give us 256 different signals. However, the ASCII code only uses 128 bytes to represent characters. The rest of the bytes are used for other purposes. The first 32 codes are reserved for characters such as the return key, tab, escape, and so on. Each letter of the alphabet and many symbols such as punctuation marks, as well as the 10 numbers, have also ASCII representation. What makes this system powerful is that these codes are standard. Did you know that bits can also be used to code pictures? Did you know that the information displayed on the computer screen corresponds dot by dot with bits held in the main memory? Did you know that on color systems, if you have 8 bits per primary color, the palette of your computer can obtain 16.7 million colors? Each tiny dot on the screen of a computer is called a picture element or pixel. Images and text are formed by combining a large number of pixels. In a bitmap display, the dots displayed on the screen correspond pixel by pixel with bits in the main memory of the computer. The bits are held in an area of the memory called the refresh buffer and are stored in groups that represent the horizontal and vertical position of the pixels on the screen and whether the pixels are on or off. On monochrome systems, 1 bit in this map represents 1 pixel on the screen and can either be on or off, or black or white. On color systems, each pixel is a certain combination of the 3 primary colors: red, green, and blue. The total number of colors which can be shown on the screen is called the color palette. The size of this palette depends on the graphics adapter, a separate video card that converts the bits into visual signals.